Today we know the working process of spark OES or spark optical emission spectroscopy. Spark SP, spark OES or optical emission spectroscopy. Spectroscopy. Purpose. It is used to determine the elemental elemental composition elemental composition of solid metal samples. Solid metal samples like ingots, like ingots of lead, etc. Now we know the how spark OES works. How spark OES works step by step. Number one, sample preparation. Sample preparation. Preparation. Sample type. Sample type is to be. Sample type is to be solid metallic sample. Example, lead ingot. Lead ingot. Lead ingot. Then surface cleaning. Grind the surface. Grind the surface in a weld weld grinder. In a weld grinder or milling machine. Milling machine. Ensure that ensure that the surface is to be smooth. The surface is to be smooth, flat, and oxide free. Oxide free. Then number two, sparking the sample. We know this process of sparking the sample. How to sparking the sample? At first the sample is placed in a at first the sample is placed on a analysis table. Analysis table. Analysis table and analysis table and electrodes and electrode touch surface. Then a high voltage then a high voltage electrical electrical discharge electrical discharge or which is called spark is generated is generated in argon gas. Sorry, is generated by argon gas between the sample sample surface and electrode. Then what happens? Then what happens? At first, this spark At first, this spark excited the atoms, excited the atoms of the sample surface. Then the atoms emitted a certain light, sorry, certain frequency of light photon. Light photon as they go to the ground state, go to the ground state. Each element, each element emit a specific element emit a specific wavelength specific wavelengths specific wavelengths of light, or which is called the fingerprint. It's called the optical fingerprint. Optical, optical fingerprint. Fingerprint. Number 3, number third is the process of optical emission detection. Optical emission detection. Optical emission detection. The emitted light is collected. The emitted light is collected by fiber optics, fiber optics or lenses, and it passed the light passed through a spectrometer. Spectrometer. And the spectrometer, what to do? The spectrometer one disperses the light, disperses the light, disperses the light using a diffraction grating, and it measures the intensity of light, intensity of light, intensity of light, of each wavelength, each wavelength of each wavelength. Now we should know the key point. Now we should know the key point. Key point. What is the key point? Number one, intensity formula. Number one, intensity of light, light proportional to concentration of element. For example, copper atom. Copper atom wavelength is 324.8 nanometer. Tin wavelength is 286.3 nanometer, and antimony wavelength is 252.8 nanometer. Data processing and result output. Now number 4, data processing, data processing, data processing and result output. First, this spectrometer data, spectrometer data is processed using pre-calibrated standards. Is processed is processed using the pre-calibrated standard. Pre-calibrated pre-calibrated standard, and then the system then the system calculate then the system calculates the concentration of each element. Then the system calculates the concentration concentrations of each element in percent or parts per million ppm. Then results is displayed within 20 to 30 seconds. Then results is displayed in 20 to 30 seconds. Output example. Output example. Output example. One example of output is, it is typical. This result is typical for refined lead. Refined lead. Refined lead. Where element and concentration data is given. Concentration in percent is given. The elements are lead, copper, tin, antimony, arsenic, and bismuth. 99 99.990. Lead is 99.990. Copper is 0.0012%. Tin is 0.0007%. Antimony is 0.0023%. Arsenic is 0.0011%. And bismuth is 0.0017%. This is the result, example of the result.